Hi, in this video, we're going to see a problem on binomial expansion. Okay, let's go over the question. In the expansion of x squared negative 1 over x whole to the sixth power, determine the term containing x to the negative third power. Okay, let's go over the general concept of binomial expansion. That is a positive b whole to the nth power. In the expansion of this binomial, the formula to find r plus 1th term is going to be NCR a to the power n minus r, b to the power r. Okay, so comparing this one and this one, I'm getting a is equal to x square, b is equal to negative 1 over x, and n is equal to 6. Okay, let's plug in these values into this formula. I mean r plus 1th term formula, that is t, r plus 1 is equal to, so 6cr, and for a we have x square to the power 6 minus r. For b we have negative 1 to 1 over x to the power of r. Okay, now what we can do is if the term containing x to the negative third power means we have to simplify the x term over here, and we must be getting the exponent negative 3. So that's a term to be considered as 1 which contains x to the negative third power. So we have to simplify the terms which contain x. Okay, let's simplify. Tr plus 1 is equal to 6er. So we can multiply these two exponents. So x to the power of 2 times 6 negative r. And so r is a common exponent, so it can be taken separately for numerator and separately for denominator. Okay, in the next step, it will be t r plus 1 is equal to 6c r x to the power of 12 negative 2r. I just distribute this 2 to 6 and negative r times negative 1 to the power of r over x to the power of r. Okay, this term. The three quantities are in multiplication here. So whenever two or more quantities are in multiplication, so the denominator in any fraction can be considered as a denominator for any quantity. So here x to the rth power is denominator of negative 1 to the rth power, but the same x to the rth power can be taken as denominator either for this one or this one, because all the quantities are in multiplication. So this time I'm going to take x to the rth power as denominator for this one. So it will be easier for me to do multiplication. Simplification. So it's going to be tr plus 1 is equal to 6cr times x to the power of 12 minus 2r over x to the power of r times negative 1 to the power of r. So now we can simplify this one easily. And here we can use a coefficient law of exponents. That is, for example, if you have x to the power of a over x to the power of b. Here, the base in numerator is x, the base in denominator is also x. I divide two terms with the same base. Whenever I divide two terms with the same base, I can take the base ones. I have to subtract the exponents, that is a minus b. So I'm just going to use this stuff over here in this term. So here the base is x, the base is x. So since I divide two terms with the same base, I can take the base ones and subtract the exponents. So I get tr plus 1 is equal to 6c r x to the power of 12 minus 2r minus r. I subtract the two exponents times negative 1 to the power of r. So our aim is to find the term, determine the term containing x to the negative third power. So in this term, we have x over here. So the exponent of x has to be negative 3. That means the value of this expression 12 negative 2r negative r must be negative 3. So we can equate this expression to negative 3 and solve for r. That is 12 negative 2r negative r is equal to negative 3. So here we can combine this negative 2r and negative r, then we get 12 negative 3r is equal to negative 3. Okay, so we can subtract 12 from both sides. So this positive 12, negative 12 will cancel out. Negative 3r is equal to negative 15. we can divide both sides by -3. When you do it, so -3 will cancel out. R is equal to negative will cancel out. Just get 5. So we get R is equal to 5. Okay, now we can plug in this value back into this R plus 1th term formula. So for, now we have to plug in R is equal to 5. So T 5 plus 1 is equal to 6C 5 x to the power of, already we know this is equal to -3, -1 to the power of 5. Okay, now we have to find the value of this 6C5. So we can do it separately. Okay, already we know a property in combination, that is NCR is equal to NC n minus R. So 6C5 can be written as 6C 6 minus 5, which is 6C1. So in this combination, whenever we get 1 over here, so the value of such combination is the 1 what we have over here. So 6C1 is equal to 6. Finally, the value of 6C5 is just 6. So we get, so the value of 6C5 is 6 and x to the power of -3. And since it's an odd exponent, this negative will remain same. 1 raised to the power of anything is still 1, so it's just -1. So finally, 6 times -1 is -6 x to the power of -3. So here 5 plus 1 is 6. So in the expansion of the given binomial x square -1 over x whole to the 6th power, so the 6th term contains x to the -3rd power. So the term containing x to the -3rd power is T6 is equal to -6 x to the -3rd power.